All right, so any questions before I dive in? So just to remind you, final exam, part one is starting Monday. I'll give you the first half of it Monday, and then Wednesday we have the second half of it, right? It should cover the material covered by tests 1, 2, and 3. I also have a alternate version of test 3 I'll be posting the solution to sometime soon, so that would also be relevant. And of course, quizzes 1, 2, and 3, and obviously also the homework which has been thus far assigned, that would also be, worth looking at. But my priority would be with questions that are already on, the test. So let's look at this one. Are there any questions you guys have in particular about test 1? All right. So I think that, if I ask you to find the equation of a line, and you got this wrong before, there's really no need to get it wrong again, right? You have a formula sheet. You can record all the, relevant ways to find the equation of a line, either with, point slope or and so forth. You could put an example. You'd have room to put an example. I'm allowing you to bring 3 pages of notes front and back to the final exam part 1, right? So, yeah. So basically, to determine the equation for a line, it's nice to know a slope, and it's nice to know a y-intercept. Then you can use y equals mx plus b. There's also the 2-point formula and other strategies, but here's the one. I don't really have much to say about problem 2. I guess I would say this is like, FOIL is great, but FOIL doesn't help you multiply this trinomial times this binomial, right? You need to think about the distributive property, and as a general guide, if you're multiplying something with, say, m things times something with n things, you should have mn total terms, right? So that's kind of a guide. I use that to help myself to figure out whether or not I missed something. If I got a sum of 3 things times a sum of 7 things, if I count, I should see 21, 21 distinct terms unless I've collected them. Not that I'm planning to give you something that has 7 terms and 3 terms and multiply it on the test. Like, the thought of grading that does not give me joy. I feel like everyone's here except for Jared. We should take this time to conspire against him. Any ideas?
I say we just all not show up Monday.
Just all not show up Monday. See, now I'm going to have to edit this video.
Okay, that's fine.
No. Do you mean I'll go to a different room?
I wouldn't show up, period. Go to a different room.
No, let's not do that.
Just all show up early.
Let's find a joke that does not throw into chaos all my grading for this semester. Let's see here. Think of something. Any questions about problem 3? Now, my advice here is if you got this wrong, then, yeah, I don't remember on an individual basis who got what wrong, but, or if anybody in here got this wrong. Maybe, I think somebody got it wrong. So here, a good way to study, and this is actually true for all the problems, is, I have posted blank copies of the test, right? So test 1, section 3, here's the test without work on it, right? So either cover up my solution or look at this, copy the problem down, try to work it out for yourself, and if you don't get this answer, then you need to figure out why you didn't, and you need to try to fix that, right? The final exam will be similar to tests 1, 2, and 3, and like I said, possibly quizzes 1, 2, and 3. So if you can understand how to fix your errors, you should have a good shot at really doing well in the final. All right, I'll get back to it. All right, so moving on. Basically, the thing is to work step by step, right? Don't try to do too many things at once, and be careful. Was people just ignored the fact that absolute value gives plus or minus. Solution and miss the -7 solution, right? Typically speaking, we're looking for two solutions for this kind of problem. And notice also that you really should be careful. Like some people also put 2x plus 3 plus 2 equals plus or minus 13. Like you can't do that either, right? We have to isolate the absolute value before we put plus minus, all right? So problem 5, how do we factor? Like what are important strategies for factoring? I'd say first of all, if there's a common x to everything, pull it out, right? That's kind of easy, right? Past that, at least think about the guess and check, just plain old, I usually just call it factoring. I mean, the kind of factoring like I did in part A, Now, if you get stuck on the guessing and checking, what could we do here for part A? What would be an alternative method? You could try completing the square, right? And if you did that and you were careful, you'd still get to x minus 4 times x minus 5. But certainly completing the square for part A on the quadratic piece would be more work, right? If you can see just plain factoring, then it's great. I would just say this, if you're not 100% sure about your factoring, take a second to multiply it back out. Check your work, right? Remember, if you do well on this test, it will replace grades on more than one test. So it could be, fixing a little mistake could go a long way on this final, right? It's worth your effort. Now, this one is the usual what's that? Oh. Is Kelsey the new Jared? What's going on here? That was Aaron. Aaron's the new Jared. You just said, come on now. I think the phrase is, come on, man. You said give you the same grades? Is that what you said? That's funny. Wouldn't that be interesting if classrooms were kind of like, like in the very olden days, two armies before they would fight, they might send a representative and have like the strongest guy fight the strongest guy and decide a battle in that way, perhaps. Wouldn't it be interesting if classes were like that? The whole semester you're picking who you want to represent the class, and then they go take a super hard test prepared by the professor. They've chose, the Marys have been chosen. That would simplify my grading a lot, but it doesn't seem very fair. So this one, come on. We have x to the 4th and x squared, so we can think about like an x squared substitution. And if you tilt your head and squint, you can see that this factors to x squared minus 4 times x squared minus 9. And then, since these are difference of squares, we have this and we have that, right? So difference of squares is important. Let's see here. Absolute value inequalities are a little bit tricky in the sense that they're asymmetrical. And by that I mean that less than is solved differently than greater than, right? For less than, we can just unwrap the inequality as a compound inequality, minus 3 less than 7 minus 2x less than 3, and then we can isolate the minus 2x, right? Why do I switch from less than to greater than going from line 2 to line 3 here? Divide by negative, right? Other important thing, remember, dividing by negative flips the inequalities. And then finally, another bit of advice, like don't express things in terms of greater than if you, it's just a bad idea. It's better to express it in terms of less than because it more naturally ties to the interval solutions, you know? So in this case, 2 to 5. I think the next problem, oh man, let me see if I can find the, I thought I had greater than on one of these. Let me try to find a greater than. Nope, that's less than. Man, don't I have greater than somewhere? Oh man, I still need to grade that bonus problem.
I've been thinking that same thing.
Yeah. Let's see here. Don't worry, I take them home with me every day, and I think I'm going to grade that when I get home. And then I don't. But I will, eventually. Where was I? Maybe I had a quiz problem like that. I'm looking for a problem with the greater than absolute value. Let's see here. Come on. Shnikes. Here we go. Part B. Part B right here on problem 9, part B, quiz 1. This is an illustration of the greater than problem. If I have absolute value greater than 5, then I have to look at it as either less than minus 5 or greater than 5. And so this case, it gives me x less than minus 2 or x greater than 3. And so the solution is two disjoint intervals, which we must glue together with the union, like so. So be aware of this fact that when we solve absolute value, if it's less than, it works different than if it's greater than. You need to be aware of this distinction and be prepared to solve either kind of problem, all right? I know it's easy enough to miss that the first time through, but, you know, hopefully final exam part 1, if I ask about it, won't be surprised. Let's see here. Problem 7, completing the square. I think a lot of you got this right. And then it weirded me out that you got these ones wrong. So, maybe that wasn't people in here, but maybe the other section, I don't remember. But a lot more people got the completing the square in problem 7 right than they did in the quadratic, which was strange to me. But anyway, any questions about problem 7? So definitely, I would want on my formula sheet, like this is the standard equation of a circle. From this pattern, I can identify this is the center and this is the radius, right? Because that's something you might want to use. I would also want the standard equation for like a parabola, right? How do you identify the vertex of a parabola off the completed square formula, you know? Completing the square is something you need to know how to do, right? So if you haven't figured that out yet, well, you got a couple more days, all right? I can almost guarantee that completing the square will be on the final exam part 1, okay? Any questions about this one? As a general point of order, like if there's a number times x squared, factor it out so you can just think about completing the square without messing with the number. That just makes life easier. So in this case, factor the 2 out. Then a half of 4 is 2, x plus 2 squared. Well, that gives me a 4. I've got a 5. So to subtract 4 from 5, I get 1. The ultimate judge of any of these things is if you multiply this back out, you get back where we started, right? So if in doubt, check your answer. even if you're not in doubt, check your answer if possible. That would be a good idea. If you check your answer, maybe then I won't have to. I'll just go, right answer, woohoo, check. That would make me feel wonderful if I graded this test and everybody had an A on it. It would give me great joy. Then I have to go back and grade them some more because I just don't feel like it's grading unless you take off points, right? I mean, you know. I'm joking. Although credit is, I have to give credit where credit's due. That's my advisor's joke. The other thing is like solving a quadratic equal to 0, the quadratic equation. Completing the square is helpful, right? Remember, if we complete the square and get a plus after the square is completed, that means there's a complex solution. If we get a minus, there's a pair of real solutions. If it's just a square, then the solution is repeated. And those three cases are also reflected by the study of the discriminant, right? The discriminant positive means we get two real roots. The discriminant 0, repeated root. Discriminant negative, complex solutions. They always come in a conjugate pair, right? For real polynomials. Any questions about this? I'm going to go on. So I haven't done too much with complex numbers, right? But here's a problem. To rationalize the denominator, we multiply by the complex conjugate over the complex conjugate of the denominator. In so doing, we get rid of the I downstairs and change it to a 10. So this is a way of bringing the I from the denominator up to the numerator. And then we just compare a plus ib to 1 minus 3i. We get a equals to 1 and b equals to minus 3. Problem 10. I think the first time this came up, maybe people weren't quite on board with it. I hope you're on board with this method by now. Some of you have gotten lucky on solving these without sign charts this semester. So, I would encourage you to use the sign chart method. Because I think that if the problem is sufficiently complicated, the other way you're doing it isn't going to work. But anyway, so here, we look at the expression. We look for where either the numerator is 0 or the denominator is 0, right? Those give me points where the expression can change sign. Because this is an inequality, comparing against 0. Another point of order, so that gives us 0, 4, and minus 6 as my so-called algebraic critical numbers, right? Then the other thing is if the power is odd in the corresponding factor, there will be a sign flip. But if the power is even, it's just going to stay the same sign. So that's why I changed from plus to minus going across 4, because x minus 4 is raised to the 5th power. And that's why I stay minus to minus as I go across 0, because we've got an x squared there. And x plus 6 cubed means I'm changing from minus to plus there. I evaluated this expression at 1 because it was easy. And when I did that, I got something negative. So that's how I put the minuses in that region between 0 and 4. And then I used the sign flipping idea to go for the other subintervals. Of course, you could also just plug in 4 points, one from each representative region, right, to decide the plus, which is plus and which is minus in here, right? Any questions? Once we've done that, we can read the answer, right? So if we want greater than or equal to 0, we need either to the left of minus 6 or to the right of 4. Now we've got to be careful. Which point should we include? Which point should we exclude? We cannot include minus 6 because that gives division by 0. But we can include 4 because that just gives us 0 for the expression. And so the answer is minus infinity to minus 6 not included because of the division by 0, union with 4 included to infinity, like that. So now this one is a little bit more annoying because it's not with respect to 0, right? It's with respect to 1, which means I've got to bring everything to one side and then do algebra so that I can obtain an expression which is, compared against 0. And then I got to simplify things a little bit, right? So do the algebra, and I end up with x times x plus 1 over x plus 3 times x minus 3. So 0, minus 1, minus 3, and 3 are my critical numbers. I put those down here in my sign chart. I evaluate at 2, because that seemed easy, and I got that as plus at 2. And then, because each one of these is just an odd power, I know that the sign is going to flip across each critical number. So I get plus here. That means I got minuses, pluses, minuses, like that. And again, you could plug in points of each representative subinterval to check on the sign choice there. But the infinity got caught off in the scan. Sorry about that. So what did I want? I want less than 0, so I need either minus infinity to minus 3, or minus 1 to 0, or 3 to infinity. And I don't want to include any of the endpoints because this is a strict inequality, right? So I'm not going to want the places which make it 0, which would have been where? If this was less than or equal to 0, how would the answer change? Anybody tell me? Again, if this was less than or equal to 0, how would the answer change here? Yes, minus 1 would be included, and what else? 0, right. In other words, the middle interval would change from an open interval to what's called a closed interval.
So how many questions are going to be on the first exam? Like 12, like the rest?
Are there 12 in every test?
That's about, I don't know.
Well, since everybody understands everything now, I can like double the number of problems, right? No? I don't want to grade that. That's a trick question.
There is about 12 on every one.
Possibly. I won't know until I make it. I might have less problems because all I have is hard problems. I might have more because I have more easy problems. It kind of depends on the nature of the problems I select from the tests. Of course, my goal with the final exam part 1 is for it to be comprehensive, because I am replacing test 1, test 2, and test 3 possibly with this test. So it should be representative of the material we've covered. Mission, what? Oh, wrong folder. All right. So moving on to test 2. A lot of people got the composition on part C here wrong. Remember, you have to actually think through it. G composed with f of 2 means G of f of 2. What is f of 2? Well, f of 2 is 20. So that gives us G of 20. What is G of 20? Well, G of 20 is given to be 11. So we get 11, right? It's not an addition. It's not a multiplication. It is the process of function composition which gets us to the number 11. We have to understand it in that way. In contrast, of course, part A and part B, we add the values at 2 or we multiply the values at 2 because those are the addition or the product functions. Very different than composition, which is part C. This one here, again, the domain is the set of possible x values. In this one, I ruled out 4, right? The range, possible y values attained. And in this case, we went from -6 not included all the way up to 6, right? Some of you threw out the number 2 in your range, but that wouldn't make sense because even though 2 in my circle's not quite where I wanted that circle to be at 2. As you can see, I kind of failed. But as you can see, that circle there is missing, right? But the value is attained over here when the input's about, minus 1.8, 1.6, somewhere in there, right? So every value between -6 not included to 6 included is attained by this function. So that's why the range is minus 6 to 6. Now, if I put a hole in the graph at the same y value both places, then that would omit a particular y value from the graph, from the range, right? Anyway, f of 4 does not exist because that hole in the graph right there. F of 2 is 6 because if we look at x equals to 2 and we go up, we have a 6 for the y value, all right? And then part E, again, we have to think through it. F composed of g of 2. Well, what's g of 2? Well, g of 2 is 2 squared plus 4, which is 8. What's f of 8? Well, that we can read from the graph, right? We go in here, go over to 8, and f outputs a minus 4 there. So the answer is minus 4. A lot of wrong answers on problem 3. A function is single valued, right? Single valued. So if I give you a function and question and you give me back a pair of answers, this is not good. The way that we work these is we say, okay, f of 2, I have to decide which recipe are we going to follow. All right, so 2 is, which case is it? It's between 1 and 3, right? So that means I use the square root of x plus 14 formula. So square root of 2 plus 14, square root of 16, I get 4 for f of 2. Minus 1. Which recipe do I use for minus 1? Well, minus 1 fits between minus 2 and 1. So I use formula number 1. This one, 2x squared plus 3. I do 2 times minus 1 squared plus 3, which is 5. All right, so when we have a case-wise defined function, we have to think about the cases, right? Decide which case you're in, use that formula, not, you can't just use both. All right, that's not correct. Problem 4, we have x squared minus 4x, carefully graph. Also write the range of the function in interval notation. So this one you probably could graph with any number of ways, but certainly if we complete the square, that's helpful because it tells us where the vertex is, namely at 2 minus 4. And so there's the vertex. And then, of course, this also has, you can also factor this, right? This is x times x minus 4, like here. So I can see that it crosses the x-axis at 0 and at 4. There and there, right? And so there you go. That's the parabola. And what's the range? Well, the y values go from minus 4 to as high as you want. So minus 4 to infinity. Any questions? So strategies for graphing quadratics, I would say complete the square and know how completing the square reveals the vertex, right? Or you could factor. And remember, the vertex is always at the average of the roots if they're real. However, if you can't factor, right, if the polynomial is irreducible, where's the vertex? See that the roots idea, it gets into some trouble when the roots are complex. Although I think that the vertex might still be at the average of the real parts of the roots. Let me look at that for a second. Let's see where the vertex of this one is. Complete the square. So if we factor this, over the complex numbers, it looks like that, right? So our roots are x equals to minus 2 plus I and minus 2 minus I, right? if we take the average of those, 1/2 minus 2 plus I plus minus 2 minus I, what do we get? So let's say this is the R1, this is R2, right? So I'm calculating the average of the roots. You notice that the i's cancel? And we get what? Minus 4 over 2, which is what? Negative 2. Where's the vertex in this one? I can see it from right here, right? The vertex is at minus 2, 1. So it looks like that the average of the roots is where the vertex is. That's true even when the roots are complex, right? But it's always the case that the vertex is halfway between the zeros of the parabola, if they're real. That geometrically makes sense. But it's algebraically always true that the vertex, the x-coordinate of the vertex, is at the average of the roots. That's even true when the root is repeated, right? So like, well, let me do it like, worthless. So this would be 5. This would be minus 2, 1 for the one I just did, right? And you know, if this is 3, right? If you've got y equals x minus 3 squared, well, the vertex is at the average of 3 with 3, right? 3 plus 3 over 2, 6. It's 3. I mean, the vertex is at the average of the roots. This one, if this is 1 and this is 6, right? Then where's the vertex if this is a parabola? It's halfway between 6 and 1, right? 6 plus 1 over 2 is what? 3.5? Yeah, 7/2, right? And just to beat a dead horse here for a second, f of x equals to x minus 1 times x minus 6. What is that? X squared minus 7x plus 6, right? So if we complete the square on that, you can see that the vertex is where? Well, it's at 7/2 minus 25 over 4. This one. So that, my picture is not great. This point, the vertex is actually at minus, well, it's at 3.5 and comma, you know, minus 25 over 4 is what? Minus 6.25, right? So my picture is not very good to scale, you know? What's this one for that example? Let me erase this. This one was so we're looking at y equals to that at the moment, right? So what's the y-intercept? 6, right? So, I mean, if I'd done this right, the vertex should be it should be more below the x-axis than the y-intercept, right? So my picture isn't quite the right, you know. Anyway, I just want to alert you to the fact we have many ways to think about the vertex of a parabola, and you should have these tools at your disposal. You don't have to memorize anything here, really. You can put it on your sheet and just know how to use it, right? But completing the square is a tool that you must have at your disposal, all right? Okay, let's move on. Difference quotient, that's pretty self-explanatory. You got to do the algebra. Notice that on the quiz there was a rather different problem, right? Remember what it was on the quiz? I think I had like 3x squared plus 2 or something. Oh, this was quiz 2, wasn't it? Let's see here. Average rate of change. Remember, we calculate the change in y over the change in x. This is that problem. Find the domain of the sum. We take the intersection of the domains, right? So at this point in the course, we're not looking at the domains being super complicated. Like finding the domain was relatively simple, right? We just basically looked at the input to the square root being greater than or equal to 0, right? But you could combine this problem with like our more complicated inequality problems, right? In principle, you could have something like, well, I'll shut up. Any questions about this one? We did this in class for a fair amount of time, right? I mean, we worked problems like this before the test. I think a lot of you got this right. For the division, we have to throw out the one which makes g 0. That's why 3 gets removed down here. How do we decide whether or not a function's invertible? Remember, it has to pass the horizontal line test. So this one does not, and so this function is not invertible. In contrast, this guy over here does pass the horizontal line test. If you pick a horizontal line, it only cuts through the black line like 1 point. So then to find the graph of the inverse, you just pick some points. All right, I picked minus 6, 6, minus 2, 4, and 4, 8. And to find the graph of the inverse, you just flip the coordinates to those, like minus 6, 6. Well, it flips to itself. Minus 2, 4 flips to 4 minus 2. 4, 8 flips to 8, 4. And so these are points on the inverse function. And so like a summary of what's going on is it's the reflection of the graph across the line y equals x, right? The graph of the inverse function, if it exists, is obtained by reflecting the graph of y equals f of x across the line y equals x, like that. So, and the graph of the inverse and the function can cross to like at the line y equals x, right? Like we saw that with the, remember if we had the base between 0 and 1, the log base like 0.5 has got a really weird graph. It crosses the graph of the exponential base 0.5. Now that I wouldn't put that on your test probably because that's chapter 4 stuff, right? But it does kind of give you an interesting, kind of different looking example of a function and its inverse function, if you think about it. Function composition is important. If you got these wrong, please take some time to figure out how to do them right. You've got to do them one step at a time, right? But there's a lot of wrong answers here. I think it was more the other section, but if they can do it, you guys can do it too. So make sure that you know how to do these. We've talked a lot more about this recently, right? If you have a linear power, it crosses. If you want it to bounce, put a square, right? So we're going to cross at minus 6, at 3, and at 7. We're going to bounce at 2. And so if you make a picture of that, it forces you that make two humps like this. So there's two maximums, two local maximums, two local minimums. I think a lot of you got this right. Is this the graph of a function? That basically boils down to, algebraically, the question is, can you solve for y? If you can solve for y is a single function of x, then it's a function, right? Do you want to graph that? I mean, I think you guys could graph this now. I think you have the tools you need to graph this. It would have asymptotes at 0 and plus or minus 1, I think.
So you said if you can solve for y, it's a function.
Yeah, if you can solve for y as a single formula. Now, counterexample. What if, y squared equals to x? Y is equal to plus or minus the square root of x, right? There I could solve for y, but it's not a function because I couldn't solve for y as a single formula for x. I mean, if you get two solutions, then you're in trouble. Do you guys remember how to calculate the inverse? We write y equals to the formula, we solve for x, that gives us f inverse of y. That's all there is to it. Of course, the algebra, can be involved, but, and then the interesting thing, of course, is if you want to know the domain for the function, that's easy. It's x not equal to 3, right? What's the domain for the inverse function? Well, y not equal to 42. But since the domain for the inverse function is the range for the function, that allows me to calculate the range in this kind of sneaky way. So that's a trick right there. Anyway, I don't know if I've talked to you guys about the solution to test 3 or not yet. Here it's posted. I think you guys are more fresh on this, so I don't feel too bad not talking about it. If you got questions about it, feel free to email me, Problem 6 was difficult, right? That was not, that was a new question. Have I talked about this already? I feel like I've talked about this already, haven't I? No? I can't remember. But anyway, the solution is posted now. I'll let you guys look at it, and I know our time's up, so I'll shut up. But notice that, I will say this, problem 10 part B was an accident. Sorry about that. I did not grade part 10, problem 10 part B. You just got credit for that, whatever you did there. So anyway, I shut up. Have a good weekend. See you Monday.